Morning, students. So this is a day after this exam, the May 2023 exam. But this paper was actually leaked. So I know CSEC is investigating to decide whether or not they're going to do a reset paper, right? Which, from my experience, that is very likely. But we're still going to work through this paper so that students can, sort of gauge their performance, gauge what they did. Right? So I'm going to do this solution and share for the class for my students and for anybody for that matter. All right, so the first question here wants us to find the exact value of this thing. Normally it would say use a calculator. So because it did not say use a calculator, I'm going to basically show some work. But initially, I'm going to work out with the calculator what it is supposed to be. So in the calculator, I'm just going to type it as it is here. Always type it exactly as it is in the calculator. So it is 5 over 6 plus 2/3. Then you're subtracting 12 over 35, and you are multiplying that by 7 over 9. And if I check the answer in a fraction form, it is 37 over 30. So this is supposed to be 37 over 30 when we're done. Because the question did not say use a calculator. I'm going to show some working. And I'm going to demonstrate that I'm using the BODMAS system. And so I'm going to work out the multiplication here first, right here. And so let me work that out first. So it will become 5 over 6 plus 2 over 3 minus, I'm going to show what this is. So that would be the 12 over 35 times 7 over 9. That would be a fraction. I still can use my calculator, but I'm showing that I'm using the correct sequence. This is 4 over 15. And then this now, you basically just add it from left to right. Right? You just add the values or subtract the values, work it out from left to right. This is addition and subtraction. So you can put that in a calculator as is. Right? Put that in the calculator as is now. And so it will be 5 over 6 plus 2/3 and then minus 4 over 15. And you will get the same answer. The same answer right here. All right, so that will be now equal to 37 over 30. And so I'm erasing this one because I'm demonstrating to the examiner that I work this part out first. This part, I worked it out first here. All right, that is that. Right, maybe put in the calculator and work it out straight and get it, give it the marks as you see. This one wants us to do this expression. Again, I'm going to put it in the calculator. Well, this one I'm definitely going to use the calculator. All right, so I'm going to put the square root of 1 minus, type it exactly as it is. It is a cosine of 37, close bracket, and then there's a square on it. So I'm going to square that. Basically, that's what we have. And that's what we have. Same thing in the calculator I have here. I want to double check that. And the answer that the calculator is giving me is 0.601815 and so on. But I want us to correct the 3 decimal places. So these are my 3 decimal places. And so I have to use this 8 to correct that 3rd decimal place. So the 8 will increase that by 1. And so the 3 decimal places, this is 0.602 to 3 decimal places. All right, that covers that one. Let's continue. This one now wants us to write this number in standard form. That number is 0.0. Let me write it below here. It is 0.00527. That's a small number. So you know it's going to end up with times 10 to some negative 4, 10 to some negative 4 as a small number. But in standard form, what it is that you want to get the decimal point right here. You want to have a number when you have one non-zero digit before the decimal point, and you multiply it by 10 to some 4, right? Standard form is also called scientific notation. The question is, what would we have to do to move the decimal point to here, after the 5? We have to move it 3 places to the right. 1, 2, 3 places to the right. So to show that I'm going to multiply by what will move it for me, I'm going to multiply by 10 cubed. This will move the decimal point for me. But then to cancel out the multiplication of that 10 cubed, I now have to multiply by 10 to the minus 3. So this and this basically cancels out each other. But what I have in the bracket will move the decimal point for me. And so it will then become equal to the 5.27. That's what this did. This moved the decimal point for me to give me that. And then I have to balance that adjustment by multiplying by 10 to the minus 3. And this is my standard form result. This is it. All right? And if you want to double check, you can put this in the calculator and you're supposed to get back that. And if you want to double check it, you know, you can do 5.27 times 10 raised to the power negative 3. And so you get back the same thing that we had before. All right? You can see that value down here in the answer on the calculator. So sometimes you have a calculator, you do something in standard form, you can put your result in the calculator to see if it is correct. All right? That finishes that part. Okay. Here now, it says Harish works at a call center and she does 35 hours each week. So this is the weekly hours, 35 hours. Or it's a he, right? He is paid a hourly rate of $11.20. Calculate the amount of money he earns in 4 weeks. 4 weeks. So what we can do is work out the weekly pay first and multiply that by 4. So if he works 35 hours and this is the hourly rate, then what he's working in 1 week, he's going to be working the product of those 2. But we want the amount for 4 weeks. So the 4 weeks pay is going to be equal to 4 times the weekly pay of 35 times $11.20. 35 times $11.20. Now I want to see what the weekly pay is because I might need it for a subsequent question. So I'm going to work this out by itself. All right, so it's going to be 35 times 11.2, and that is $390. So this becomes 4 times 392, 392. So this is a weekly pay, but they wanted 4 weeks, right? So we're going to multiply that by 4, and that is 1,568. That's for a month, 4 weeks. Remember now, the weekly pay is this amount if we want to use the weekly pay, 292. All right. Next question says, in a certain week, see, going back to a week. In a certain week, Irish work 8 hours overtime. Overtime hours is paid at time and a half usual rate of this. So basically, to get overtime, we have to multiply 1.5 times this. Right? They want us to calculate the total amount Irish work that week. So the total amount work that week would be the basic pay, which is the $392 plus the overtime pay. Right? And remember, it's 8 hours overtime. So let's work it out one step. So the total pay, let's work it like this, will be equal to the basic pay which is a regular pay, plus the OT. OT means overtime pay. It's going to work it out one time. So the basic pay for the week is going to be the 392 that we calculated here as the amount for basic pay, 35 hours. So it's 392 plus the overtime pay now. Firstly, the overtime rate is 1.5 times this, and it did 8 hours. So basically, let's multiply those values. Right? It says 8 hours overtime, 8 times the overtime rate. And the overtime rate now is 1.5 times that. 1.5 is the same as 1.5 times the regular rate. That is $11.20. I don't need to actually work out the overtime rate, but this would be the overtime rate when I multiply those two. And they did 8 hours of that. So this calculation would give me the figure that they want. Total amount that you work that week, which will be the basic plus the overtime. I'm just going to put everything in the calculator. That says 392 plus 8 times 1.5 times $11.20. And that answer is 526.4 means 40 cents. So that is the total pay that week. We're gonna do the mathematics the easy way. All right, two marks for that. We don't need to show more working than that. All right, everything is placed there. All right, let's continue. Everything is explained. All right, so we're on to number 2, which wants us to simplify this expression. So it's your basic simplifying of fractions. So this has an x here and an x here. They cancel each other. And then 5 into this is 1 time, and 5 into that is 3 times. All right? Or you can say 5x into 15x is 3 times. So in any case, 1, 3. And then you're canceling down on the 4 and the 16. So it's 4 into this 1 time, 4 into that 4 times. So the result becomes 3 over 4. 3 over 4. This result is 3 over 4. But I don't like to cross my work like this. Right? With all these crossings. I don't like to cross it like that. I'm going to clear it. I know that the result is 3 over 4. And I explain why it is 3 over 4. And so I'm going to clear this. It is 3 over 4. Right? Remember, this into this is 3 times. And this into this is 4. So it's 3 over 4. That is correct. That is 3 over 4 the answer. Next question. It wants us to, let me change the color of this thing. Let's change the color to blue. Okay. All right. So here now, we're required to solve this inequality. Now remember, solving a linear inequality, this nature, is the same process really as solving an equation. The same values. The only difference is that if there comes a point when you have to multiply or divide the inequality with a negative number, you have to remember to reverse the inequality sign. Right? You have to remember. So it will basically be the same steps as solving 12 minus 4m equals 5 minus 8m. Basically trying to make m the subject. But with this one, you don't need to reverse any signs. It's an equal. With this one, if there comes a point where you have to multiply or divide with a negative number, you have to remember to reverse the sign. All right. So basically trying to get the m terms on the same side. So this negative 8m, I'm going to bring it on this side. It's going to become a positive 8m. I'm trying to put it with this one. And then this 12, I'm going to take it over onto that side. So these are the two things that I'm moving. I'm going to move this negative 8m. I'm going to move this 12. All right. So now move the 8m over onto this side. It becomes a positive 8m. This minus 4m remains there. Less than or equal to, this 5 remains over on this side. And then this 12, when it goes over here, it becomes negative 12. All right, that's a simple way to do this transposition. This 8m minus 4m is 4m. Less than or equal, this becomes a negative 12. 5 minus 5 negative 7. 5 minus 12. 5 minus 12 is negative 7. Then it's a matter of dividing through by 4. Dividing both sides by the 4. All right? And it's a positive number I'm dividing with. And so there's no need to reverse the sign. So m becomes less than or equal to negative 7 over 4. That is it. Now let me just show you if I wanted instead to transpose the m onto the left side, right? Let me show you how the result would change. Well, not change, but the same, but the working would be a little bit different. All right, so if I were to move these instead, if I were to move this 4 onto this side and move this 5 onto this side, so let's say now I'm moving this and I'm moving that. I'm trying to get the m on the right side. Then I would have 12 over here. This 5 would go over on the left side and it will become minus 5. The sign is less than or equal to, I have a negative 8m here. And then this 4m will come over onto the right side, become a positive 4m. And so this side becomes 7 less than or equal to, this is negative 8m plus 4m will become a negative 4m. But now, if I divide through by negative 4, then I would have to reverse this inequality sign for it to remain true. So let me write it out for you. If I divide by negative 4, because I'm dividing with a negative number, I would have to reverse that less than or equal to sign in order for the inequality to remain true. And so if I divide by negative 4, this becomes 7 over negative 4. This inequality sign is reversed and becomes greater than or equal to. And then when I divide this by negative 4, only m remains over there. So this result is the same as this, okay? Because reading this from left to right, it means m less than or equal to negative 7 over 4. Read this one from right to left, then it is saying m is less than or equal to negative 7 over 4. So essentially, it's the same thing. I could actually flip this and write it as m, that's this one. Flip it and write it as m greater than or equal to 7 over negative 4. And 7 over negative 4 and negative 7 over 4 is the same thing. No difference, it's the same thing. All right? It's the same thing. But this is the way we could have done it. If we did it away, we have to divide by a negative number. We have to remember to reverse that inequality sign. All right? In any case, that is the answer. M less than negative 7 over 4. Right? M less than negative 7 over 4. All right, our m greater than, made a mistake here. This should be less than or equal to. Right? So turn it around. It's less than or equal to. This is the same as this. Less than or equal to 7 over negative 4, which is the same as that. All right, enough of that. Next question. All right, so they give us this diagram. So the diagram below shows, I don't need a calculator. All right, so the diagram below shows a compound shape, LMNPQR, made from 2 rectangles. So you have a rectangle here, and a rectangle here. 2 rectangles. It says the length in the diagram, which are written in terms of x, are in centimeters. So these lengths are centimeters written in terms of x. You can notice that they did not give us any dimensions for that piece or any dimension for that piece. All right, no dimension given for those pieces. All right, the question says, say first thing I want is for us to find an expression for PQ, which is here, and an expression for RQ, which is here. All right, so PQ first. Remember, it's a rectangle. These two sides will be equal. Right? Overall, that will be equal to 3x. But this length right here, the same length right here, x plus 3. Plus 3. All right, so let's put it there. So this is x plus 3. And overall, This is 3x. So I mean that this piece here, PQ, actually then is 3x minus x plus 3. 3x minus x plus 3 would be equal to the length PQ. So we can write that PQ is 3x minus x plus 3. So it is 3x minus the x, which is 2x, and you're subtracting 3. That's minus 3. That is that. All right. You can double check it by adding the 4x plus 3 back with this x plus 3, which will be right here. X plus 3. If you add those, x plus 3, 3x minus 3, and 3x plus 3, 2x minus 3. You add back the 2x minus 3 and the x plus 3, you're going to add back to the 3x. So you can just double check that way. So let's put stand there. This length right here is 2x minus 3. All right, next part is for us to find this length. And a similar way we're going to calculate it. Total length across here is the same as up here. 4x minus 5, 4x minus 5, 4x minus 5. But this piece right here is the same as this, x plus 1. So to get here, the RQ is going to be 4x minus 5 minus the x plus 1. All right, so let's write it out here. This becomes 4x minus 5, which is a whole length, minus x plus 1 minus x plus 1. And so it's 4x minus x is 3x. And then minus 5 and minus 1. Minus 5 and minus 1 is negative 6. That's it. And yeah, again, you can double check it. You can double check it because with this length, put down now, is 3x minus 6 right here. This is 3x minus 6. Right? So 3x minus 6 and x plus 1 must be equal to 4x minus 5, which it is. Right? So let's write that a little bit better. This is, did I say 3x minus 6? 3x minus 6. All right, so I found those two, right? One mark each. Let me erase this. The next part says, given that the total area is 414, we are to show this equation as a quadratic equation. So the total area is 414 centimeters squared. So let's look at it. So what we can do is break down the shape into two rectangles. Just divide it across here so we can just extend this side. And then it becomes two rectangles, rectangle 1 and rectangle 2. And so basically calculating the sum of those two areas, and they should be equal to this. Right? So we can write something to say area 1 plus area 2, area 1 plus area 2, area 1 plus area 2 is equal to 414. That's what the question said. Right? 414. What's the expression for area 1? Area 1 is the product of the 4x minus 5 and the x plus 3. 4x minus 5, x plus 3. Let's do that. 4x minus 5, x plus 3. 4x minus 5 times x plus 3. That is area 1 plus area 2 now. Let's look at area 2. Area 2 now will become 2x minus 3, x plus 1. 2x minus 3, x plus 1. 2x minus 3, x plus 1. 2x minus 3 times x plus 1. All of that is equal to 414. And so we just basically expand out this equation now, simplify it down to this. All right, so let's expand this side first. Now, when we expand this side, right, it is 4x times the x first, which is 4x squared. Then the term in the middle is the sum of the far product and the near product. Second term is the sum of the far product and the near product. The far product right now is 12x, and near product is negative 5x. Negative 5 times x. That gives us a middle term. We're always going to do the mathematics the easy way. So 12x minus 5x is 7x. So my middle term here is 7x. 7x is my middle term. Plus 7x. And the third term is the negative 5 times the 3. Second product of the second term, that's negative 15 minus 15. So this is what we get when we expand here. And we'll do a similar expansion for this. So firstly, it is 2x times x is 2x squared. Again, the middle term is a far product and the near product. Far product and the near product. Far product is 2x, the near product is negative 3x. Negative 3 times x is negative 3x. So negative 3x and 2x is negative x. My middle term there is negative x. I'm going to put minus x on my middle term here. And then the third value in this expansion is negative 3 times 1 is negative 3. And that is equal to 414. But because this has a 0 here, I can transpose the 414 and make it minus 414. And put that equals 0. Let me shift so a bit. Put this equals 0. And when we consolidate the values, we are supposed to get this, right? So let's look at it now. So firstly, it is 4x squared and 2x squared, 6x squared. So naturally, we're going to have to divide through by 6. And then this is 7x minus x. 7x minus x is 6x. Yes, 6x. And then we're working these numbers now. This, and that. What does that add up to? Let's just jump for the calculator. Right. I don't want to waste my brain power right now. So let's work those numbers quick. So they're all negative, right? These numbers are all negative. So you know, we minus the sum of these values. 15, the 3, and the 414. So 15 plus 3 plus 414. 432. So you're subtracting 432, which is equals 0. And then we have to divide through by 6. We have to divide through by 6. Divide through by 6. Divide through by 6. So dividing each of these values by 6. And so we get x squared plus x. And then we divide this by 6. Let's look at it. 432 divided by 6 to get the 72 minus 72 equals 0, which is the same thing that they gave us there. So this was shown. Nice question for 4 marks. All right, that is that. All right, so that is shown. Do you want us to solve it? No, question is right there. All right, so that finishes that question. Let's continue. Next one. Next one is here. All right, so this one now they give us this diagram. So the diagram below shows a semicircle. The diameter is AC. That's a diameter AC. It says B is a point on the circumference, and our diameter subtends 90 degrees. So right off the bat, I know that this is a right angle. The angle in a semicircle is 90 degrees. Then it says AB equals BC is 8.2. And I could see that this length and this length is the same. It's 8.2 because I put the same marking on both lines. I know that they are equal in length. So let's complete this and write the 8.2 and this as well. 8.2 centimeters. So we have a right angle triangle here, guys. Right angle triangle. And since we have a right angle triangle, we can use SOHCAHTOA tool in it. Right, that was a steering. All right. Question says state the name of the line AB. This line is AB right here. Line joining circumference is called a chord. So that's a chord. Line joining 2 points on the circumference of a circle is called a chord. Because if you complete the circle, it will be like this, you know. Right? This is just half of a circle, but if you complete it, will be like that. But that will be a chord. Right? Just the same. So this is a chord. All right. Then it says, find the value of the radius of the circle. The radius. All right. So this is the diameter. If we can find the length of the diameter and divide it by 2, then that will be the radius. Because this is a right angle triangle, this is the hypotenuse. This side is the hypotenuse of the right angle triangle because it is opposite the 90. Remember, this angle here is 90 degrees. Why is that 90 degrees? Because angle subtended by a diameter in a semicircle or in a circle is 90 degrees. Right? So the hypotenuse is the diameter right now in this triangle, focusing on this triangle. Right? So that's the diameter, and the radius is half the diameter. So let's write that. So the radius is going to be half of the diameter AC. What is AC? Using Pythagoras' theorem, AC, which is the diameter here, in Pythagoras' theorem is the square root of the product of the square of the sum of the square of the other two sides. And hypotenuse will be equal to the square root of A squared plus B squared. This is A and this is B, but they happen to be equal, right? This question. So in any case, we're working it out. It becomes half the square root of the 8.2 squared plus 8.2 squared. That will give us our radius. I'll go on. Let's get a calculator and let's do it. That will give us the radius quick and fast. Let's just calculate it here. Radius. So we're doing a half times square root of 8.2 squared plus 8.2 squared. That's 5.798, 5.80 centimeters. Okay, correct the three significant figures, 5.78. All right, we can double check this now because this can be done another way. Because what if we were to break it down and say show the radius? So for example, this would be a radius. This apex line would be a radius. And if I assume that this is the center of the circle, and this would be 90 degrees. It would be 90 degrees, right? And this would be a radius, and this would be a radius. So it means that since this is 90 degrees, these two angles will be equal to 45 degrees each. Let's use another method just to double check it. So this will be 45 degrees. 45 degrees. And then we could say sine of 45 equal opposite over hypotenuse, where the opposite is radius. Or we could say cos of 45, it doesn't matter. So let's bring it another way just to double check. So we could say using this tricks to calculate it, we could say the cos of 45 degrees equals adjacent, which is r, radius, over hypotenuse, which is 8.2. And then to get the r, we would multiply the 8.2 over here. And so the r, radius, would be 8.2 and the cos of 45 degrees. Now let's see if that gives us the same 5.8. So give us the exact same value that we got in the calculator before. 5.79 something. That same exact value we're seeing on the calculator now. If it is correct, this calculation will give us the same thing. 5.79827. Same thing. Let's look at it. 8.2 times the cos of 45 degrees. See? Same exactly. That confirms it for us that the radius indeed, the three significant figures is 5.80 centimeters. Done two different ways, same answer. All right? So that is that. Let's continue. All right. Next question. This question says each angle in a regular polygon. Now, this word regular polygon is very important. Regular polygon means all sides equal. And also all angles equal. And a polygon is regular, all sides equal, all angles equal, like a square. Right? All angles equal, all sides equal. And also each angle in there is 160 degrees. Calculate the number of sides in the polygon. Let's say that number of sides is n. Right? So we're trying to find n. Now, the formula for the total interior angle of a polygon. So a polygon can be broken down into n minus 2 triangles. So we're going to use that to solve it. Total interior angle. Total interior angle of a polygon. Right? That's what we use it. Total interior angle of a polygon is n minus 2 triangles. Remember, we're trying to find n now. So the formula would be n minus 2. Now the triangle, so it has n minus 2 triangles. And the triangle is 180 degrees. So it's n minus 2 times 180 degrees. That's the total angle in any polygon of n sides. But because they tell us that each angle in there is 160, and there are n angles, the number of sides is n, the number of angles is also n. The number of sides and the number of angles in a polygon is the same. So this total will also be equal to 160 degrees times n. That's how we're solving this. You know? This is a normal formula for the total interior angle of a polygon. But because this one is regular, means that all the angles are the same, and there are n angles, and each of them is 160. So this also represents the total angle. So once we solve this equation now, that will give us the n. So we're going to expand this out first and get 180 n minus 2 times 180 is 360. 360. And that is equal to 160 n. All right? We're dropping off the degrees. I've taken off the degrees. I don't need it. I'm going to transpose this 120 and subtract from the 180. I'm going to get 20 n equals transpose this 360 over here and get 360. 360. And if I divide 2 by the 20, I get 18. So I divide the zeros first, the tens first, and then it's 36 divided by 2. And 36 divided by 2 gives me 18. The number of sides is 18. All right. Okay, let's do a quick double check right here. Our calculation is correct. Let's double check it because I'm just making sure when we're trying to get the right answer. Let's double check it quick. So if it's 18, then the total interior angle would be 18 minus 2 is 16. 16 times 180. 16 times 180. That's 2880. And then it's supposed to be still 160 times 1870. Right. So it is correct. I'm just double checking. So that is it. Polygon has 18 sides. 18 sides is the answer. All right. 360 divided 18 sides. All right. Let's continue. Okay. All right. Then we'll come to this diagram now. We will need a calculator for this one. This is a transformation now. So the diagram below shows a trapezium A drawn on a square grid. So this is our trapezium A. So we're going to ask us to do some transformation on it. It says on the diagram above, draw the image of A after it undergoes a reflection in the line x equals -1. Remember, the line x equals -1 is a vertical line now, passing through -1. Remember, the y-axis is x equals 0. So x equals 1 will be vertical like the y-axis, right? And this is -1 here. So the mirror line really is this line. This is our mirror line, the reflection. vertical line passing through -1, x equals -1. And we'll do our reflection, we'll do 1 point at a time. Let's use the blue just to make sure. So reflect this point first. It is 2 units to the mirror line. It's going to go 2 units on the other side. So that point is coming here. All right. And then if we do this point, it is 3 units to the mirror line. 1, 2, 3. It's going to go 3 units on the other side. 1, 2, 3 here. Do it 1 point at a time just to make sure. And then this point at the back is 4 units to the mirror line. It's going to go 4 units to the other side to here. And similarly, this point is 4 units to the mirror line. 1, 2, 3, 4. It's going to go 4 units on the other side. 1, 2, 3, 4, right under this point to here. So those would be basically the vertices on the image. All right, so do your reflection 1 point at a time just to make sure. All right, with experience, you might only need to do 1 point and then draw the other points in place. Or to be safe, do it 1 point at a time. This is the image. All right, they want us to label it anything. So label it A prime. Label it A prime. So this is A prime. A prime. All right, next thing I want us to do is to do a translation. Remember, it's a translation. This value is the horizontal movement, and this value is the vertical movement. All right, now, because this is positive, it means that we are going to the right. When this is negative, it means that we are going down. So this translation will move a point 4 units to the right and 7 units down. It's a -7, 7 units down. So we just need to look at that original A, right? Original A, shape A, and do this movement on it. I will only need to move 1 point now, because when we do the translation, the object just changes its position. There's no turning, there's no change in size. So we can move 1 point and then draw about the same shape around that 1 point. All right, so let's say we'll move this point. 4 units to the right, this is a different color. 4 units to the right, 7 units down. 4 units to the right, 7 units down. So moving this point. So it's 1, 2, 3, 4 units to the right, and 7 units down. That's what it is, 4, -7, right? Oh, just making sure. 7 units down. So it's 1, 2, 3, 4, 5, 6, 7. So that point is coming here. That point is coming there. This point is coming here. So basically, we just need to draw about the same shape around that point. Let's do it in blue. So this side is 2 units this way. We have this vertical side 2 units up here. Then this side at the top, 1 unit. And then we have this slant side. This slant side. So that blue trapezium is our result of our translation. But we did 4 units to the right here. We did 7 units down here. All right, and so this is our A double prime over for the blue. This is our A double prime. A double prime. All right, and we can take these lines off. Don't need them. Take these off. That is it. Okay, that finishes that question. This is an easy translation question. I've seen transformation questions that requires far more work than this in the past. This is a very easy one on this paper. This question, functions. It gives us these 3 functions, f, g, and h. This one is a quadratic, right? F, g, and h. Let's write them out. So they give us f of x equals 3 over x plus 2 and it gives us g of x equals 4x minus 5, and we're given h of x equals x squared plus 1. All right. First thing we want is find what value of x. What value of x is f of x undefined? No, f of x, as you can see, is a fraction. Fraction becomes undefined when the denominator is equal to 0, because we cannot divide by 0. A number undefined means that undefined is a quantity that we don't know what it is. That's what undefined. And a fraction becomes undefined when the denominator is 0, right? So it's when this denominator is 0. Because when the denominator is 0, f becomes 3 over 0, which if you put this in the calculator, you're going to get an error message. Cannot work out, right? Because basically this is an infinite number of times that you can take 0 from 3. So it's basically when the x plus 2 equals 0, which is when the x equals negative 2. So this is the answer. Right? X equals negative 2. All right. Next part wants us to find g of a quarter. So it means that we'll just plug in the quarter in the g function where x is right there. Right? So it becomes 4 times a quarter. 4 times a quarter minus 5. 4 times a quarter is 1. 1 minus 5 is negative 4. So that answer is negative 4. Next thing we want is h of negative 3. So it means that taking this, let me copy this down. All right, no, don't have to. We're going to take this negative 3 and drop it in the h function. So become negative 3 squared plus 1. Negative 3 squared is a positive 9 plus 1. So that result is 10. So 10 is the answer right here. That's an easy. So we're doing f of 0. Let's copy down f again. F is this thing, right? We'll just copy it down. Copy it. This is the one name. So it's in front of us. Let's just open it here so we can see. So f is this. F is that function. And if you do f of 0, and remember, this could have been also written f squared of 0. Same thing, right? So if they give you this, it means the same thing. All right. Now, f of 0. F of 0 means doing f of 0 first. So it's the same as f of 0. And f of 0 means that they put in 0 for the x right there. So it will become f of 3 over 2 if you put 0 here. And then f of 3 over 2 now, let's try that bit. Means that you put in 3 over 2 for the x right there. So then that would now become 3 over 2 plus 2. Where this x is, you put in 3 over 2 there now. And basically now working this out. If you want, you can drop it on the calculator. You can work it out. We could work it out. 3 over 2 plus 2. Cancel this fraction under here. I could multiply the numerator up here by 2 and the denominator by 2. So multiply this numerator by 2. I'm gonna get, so for the blue, I'm gonna get 6. And right here, multiply this by this, I'm gonna get 3. And then multiply this by this, I'm gonna get plus 4. So it is 6 over 7. This is a 7. 6 over 7 is the answer. Right? If you were to work it out step by step, if you show this on the calculator as well, so make sure you want to use a calculator to do it. It would be fraction. I think that's what most persons would do, but you put in a fraction here as well. And then you add the 2. Look at that other fraction. See, you get the same 6 over 7 right here. 6 over 7. So 6 over 7 indeed is correct. Next part. Next part says write g of h in the simplest form. We must calculate g of h. Yeah, g of h. No, g of h it means H into G. It's a simple way to say it. It means H into G. Now, let me copy the two functions down and show how we would do that, right? So let me copy both of them here down. That's what we need. And show how we construct this thing. We can fast paste. So these are the two functions. We're trying to put the H into the G. So when you put the H into the G, this is a whole H. All right, you're gonna bring it and drop it into the G where the X is. That's why you form the G of H. You put H into the G. So we can do that construct and write G of H of X equals H into G. So you put back the 4, where the X is, you put the X squared plus 1. And you put back the -5. So where that X was up here in the G, we have placed all of H there. And the question says simplify. So this guy, we're going to expand this out. We're going to get 4 times X squared is 4X squared. We're going to get 4 times 1 is 4. 4 minus 5 is -1 minus 1. That is it. Simplest form. That's the answer. So this construct was just to show you how you actually do this composite, all right? Put into H into the G. All right. Let's continue. Next here, we want us to find G to the -1 of -2. So naturally, what persons would do for this, they would calculate G to the -1 of X first. And then substitute the 2. All right, so how do we do G to the -1? I'm going to show you another way to do this question as well this one time. So over the G is this 4x minus 5. So I'm going to write, to calculate the G to the -1, I'm going to write G equals 4x minus 5. I'm going to inverse this. So the G becomes X equals, and the X becomes G to the -1. 4 times G to the -1 minus 5. When I make this a subject, it means that I now have my inverse. So to make this a subject, I'm going to move this 5 first. It becomes X plus 5. And then I'm going to divide under this 4. X plus 5 over 4. That becomes my G to the -1. And if I want G to the -1 of -2, it's just a matter of putting the -2 here now. Because now I can put in back the of X on this. So if I want G to the -1 of 2, it's just a matter of -2 is a matter of plugging the -2 there. So I can write that now. So therefore, G to the -1 of -2 becomes a -2 plus 5 over 4. What is the same as 5 minus 2? 5 minus 2 is 3. Plus 3 over 4. All right, well, let me show you another way you could do it here if you can fast. Let's put it in this box. So this is our OR method. Right? A method that we can use. We don't need to calculate the G to the -1 first. So in this method, I'm going to say, let's do it anyway. I'm going to say, it's like we put this equal some number, right? We're going to say, put it equal n. So G to the -1 of -2 equals n, some number. So it means that the -2 is equal to G of n. So you're really solving G of n equals -2. That's what you're really solving now. G of n equals -2. Remember that this is G of x right here. G of x. This is G of x. So G of n means this is G of x. Let me write it here. G of x is this here. This is G of x. So if I want G of n, it means that I'm replacing the x with n. So I'm really solving -2 equals 4n minus 5. When I calculate n, I have my answer. When I calculate n, I have my answer. I'm saying G of -2 equals n. When I find n, I have my answer. So to find n, I would carry over the 5 and then divide by the 4. So you can say that the n would be equal to, carry over the 5 becomes a +5 minus 2 divided by this 4. You'd have to divide by that 4. And this will be 3 over 4, just the same, right? So you get n equals 3 over 4, just the same. Let's break this down. Like so. So you will get the n, this n equals 3 over 4, just the same. Which is the same answer that we have here. So that's another way we could do it without actually finding the g to the minus 1 first. All right, so more maths equals better maths. All right, and something you have to learn different ways of doing questions. And we do questions using different methods. It helps to understand the subject a lot better. All right, so let's continue. This question now, number 5. So number 5 says, each of 75 girls, 75 is a total, recorded the name of their favorite sport. It's a statistics question. The number of girls who chose track and cricket are shown on the bar chart. Track and cricket. All right, so track, this is cricket. Now, what you want to do, where you start, is to read your scale properly. All right, read your scale, see what the scale is. Now, this is 0, that's 4. So it means that right here is 2, right here is 6, right here is 10, right here is 14, right here is 18. They fill them out, right? Right here is 22. All right. Oh, by now, you're counting students, and so there's no 18.2 students. So, for example, right here, you have 18 and then 20. So the only number that you can use between 18 and 20 is 19, which would be basically right halfway between them. 19. You cannot have 18.5 girls. It's just 18, 19, 20, right? All right, so let's be mindful of that. So we're working with the halfway mark as well in between these. For example, right here, the 70. All right, so let's be mindful of that. All right, so question says, how many more girls choose cricket than track as their favorite sport? So basically, it's a difference we want. How many more? We want the difference. So we need to know how many girls do cricket and how many do track on the graph, right? So we can write it on it. So this is cricket. Right here is 16. Right here is 18. So this must be 70. Right? So that must be 17 halfway. So I'm going to write it up here. 17. So this is 17 up here. This one clearly is just 12. 12. I'm going to write the 12 up here. So you have 5 more up here than this. 17 minus 5. 17 minus 12 is 5. So if you want, you can just write the 5. But you can show the correction. 17 minus 12, which is equal to 5. 5 more girls. So this is the answer, 5. All right? Next question says 11 girls. 11 girls. 11 girls recorded tennis as their favorite sport. I'm going to put it on the graph right now. I want to know. So tennis here. 11 girls recorded tennis. I'm going to just put it on the graph from now. So this is 10 and this is 12. So the 11 is right in between here. We're going for the tennis. So the tennis bar is this bar up here. This is the tennis bar. And using the same scale, same width as these, same width. And you're coming right halfway between the 10 and the 12, right? Halfway. And this is 11. 11. I'm gonna just some marking as if I'm shading it, right? I'm gonna shade it fully black like this, you know. You have time for that in the exam. This is sufficient if you just shade it like that. All right? That is the bar for tennis. I'm putting on the diagram. The more information you have on the diagram, the better. That's 11. My pen not working so well enough, guys. So to be right. This is 11. All right. So it says the remaining girls. For the remaining girls, the number who chose swimming compare the number who chose football is 2 to 3, 2 to 3. So basically what they're saying is that swimming to football, let's set it out. Swimming to football is 2 to 3. It's 2 to 3. It's 2 to 3. And this is the remaining girls. The question is, how many girls have we accounted for so far? These. We accounted for those girls so far, and the total number of girls was 75. So let's see how many girls combined for swimming and football first, and they're in the ratio 2 to 3. All right, let's look at that. So let's just calculate it quick. So remaining girls would be 75 minus the 11 minus the 12 and minus the 17. So I have 35 girls going to go on. 35 girls. So we know that these are up to 35. No, this isn't a ratio. I always tell the students, ratio is just a broken down comparison of your actual values. All right. So I'm going to set up my ratio like this. Know that I want to know the actual number for swimming and the actual number for football. What I know is that the total is 35. So I'm going to put in a part of the ratio for my total between these two, or my remaining students. Remaining, let's call it remaining. It's 35, but in the ratio 2 to 5. So the total of that ratio is 5. But my actual is actually 35. So if I want to show my actual in this ratio, then this 5 has to become 35. So I need to multiply my ratio by 7 to get the actuals. All right, let me shift this over somewhere so I can show the work. All right, so this is just my work to get my actual numbers. Right, let's put it over here. Good. So I want to show my actuals. So I know that my actual remaining students was 35, but the ratio, the broken down ratio of that 35 is 5. So to multiply back up to what it actually is, I have to multiply by 7. I multiply by 7, this remaining total box shows me what I want, which is 35. And the other part will show me what they actually are as well. So when I multiply this by the 7, I'm going to get 21. When I multiply this by the 7, I'm going to get 14. You see that when you add the 14 and the 21, they add 35. So it means that the number for swimming is 14 and the number for football is 21. Simple like that. So I can go and put them on my calculator, put them on the bar chart. 14 for swimming, 21 for football. 14 for swimming, 14 here. 14 is right up here. So 14 for swimming. 14 for swimming. That's my swimming bar. I'm going to put 14 on top there so I don't forget it. And 21 for football. The football coming all the way up to here. So the 21 line inside there. So 21. So 21. Halfway between the 20 and the 22. Make sure you put it precise. This graph is not clear. So if you use the correct graph and the correct scale, you come in at the midway point inside here. All right? This will be 21. This is my football bar. So I know I have all the actual information. So because I know I have all the actual information, I can answer anything now. It's always important to know what the actual values are. So generally speaking, when I'm given data in a ratio format, I build that ratio back up to the actual. Because if you know the actual values, you can calculate anything. Right? It says use the information to complete the chart. So I did that by calculating the number for football. So this calculation really needs to be a part of your solution over here. I want to show some work. And they say now we are determining the modal sport. Modal sport is football. Most girls do football. So modal sport is football. So the answer for this one is football. Modal sport is football. And let me just change the color of my calculation. Well, leave this, put the calculation in a box. So my calculation, let's put it in a purple box over here. It didn't give us much space to work with this one to show my calculation, but that's it. So put information on the chart. So we had to work out the number for each one, for swimming and football. I use a ratio method to do. All right, so that is that. All right, so put the bars on the chart. All right, that's it. This one said, one girl, so it's a probability now. What's here, one girl is selected at random. What is the probability that she chose neither track nor cricket? All right, so I want to know how many chose neither track nor cricket. We're talking about the remainder, the remaining girls. So we don't want these two. We don't want track, and we don't want cricket. So these are the girls that we want right now. 14, 11, and 21. Remember the 14, 11 was 35, and so we just worked out, plus this 11 makes 46. 46, right? So clearly it's 46. 14, 11, and 21 are the girls we're talking about. That's 46. Right. So, but 6, you're gonna want it to show working. Let me take these off. So it's 14, 11, and 21. Talking about 14, 11, and 21. Go on the track off football. 14, 11, and 21. So it's becomes equal to equals 14 plus 11 plus 21 over the total of 65 girls. No, it was 75 girls. 75 girls. 75 girls. Right. It's 46 over 75. That's it. 46 over 75. Next question says, information of the favorite sport of the 75 girls to be shown on a pie chart. Calculate the sector angle for football. So remember, football was 21. What are the total students is 75. That will be the fraction of the total. We want that fraction out of the 360 degrees in the pie chart to get the sector angle. So multiply that fraction by 360. 360 degrees. That will be your sector angle in a pie chart. Fraction of the total. I need to put that out of the 360. So that will be 21 over 75 times 360. That will be equal to 100.8 degrees. That will be the sector angle for football. Nice and easy. Just stand down. All right. Next question. Next question down here is number 6. So number 6 is some measurement, right? Pi is 22 over 7 in this question. Volume of a cone is 1/3 pi r squared. So one of the calculate volume of a cone somewhere in this question. I use that formula somewhere. Question says the diagram below shows a sector OMRN of a circle. Center is O, the radius is 12, and the sector angle is 168 degrees. So everything that they have said here is on the diagram. All right, it means that this length also is a radius of 12 centimeters, and the sector angle is 168. All right. Then the question says calculate the perimeter of the thin metal. So that thin metal. It's a thin metal. I just say that made from the thin metal sheet. Oh yeah, made from a thin metal sheet. Right. So we want the perimeter. So the perimeter is the distance around it now. 12 plus the arc plus the 12. So basically 2 12s plus the arc length, right? That gives us the perimeter. Right? So the perimeter is the arc length plus 2 times the radius. Let's write it this way. The perimeter equals the arc length. The arc length. Let's say arc. Arc length. Arc length plus 2 times the radius, which is 2 times 12. The arc plus that 12 plus the 12 give it perimeter, distance around. All right. What is the formula for the arc? Arc is a fraction of the circumference. What fraction is that? 168 over 360. 168 over 360 is a fraction times the circumference would have been 2 pi r. 2 pi r, the r is 12. And then you're adding back this 24. 2 times 12 is 24. All right? The formula for the length of arc is a fraction of the circumference. Circumference is 2 pi r. All right? So let's work that out with the calculator. Let's see. All right, so we can work out this part, the arc length, and then add it to 24. We're going to need the arc length in another part of this system. I read it through before. So 168 over 360 times 2 times the question, so must use 22 over 7 for pi, right? So for this pi, we're using 22 over 7. So it's 22 over 7, and we'll multiply that number by 12. So we have 35.2, and you add then 24, and then you complete that by adding 24. I just wanted to see what that arc length was. We have 59.2. That's 59.2. Let's shift this over a bit. Write the unit. Write the unit. So 59.2. You have to say centimeters. You have to write the unit on the answer, right? It's unit centimeter. That's it. So this is the length of this arc right now. That's the length of that arc, 35.2 centimeters. All right? So it's 8 over 360 times 2 pi r. Okay, good. That is that. Next part now says, it says a cone is made from the sector by joining OM and ON as shown below. So what happened is that they form the sector, form the cone. This is really the net. This is really the net of a cone. You know? That's what this is. You know? The net of a cone. That's the net of a cone. You know? So the net of a cone is basically like you take a cone and you flatten it up. That's what the net is. Now, if you pull, let's imagine that you're pulling this point upwards towards you, pulling it up towards you. Right? Then what happens now is that these two sides basically come and join together. Right? And then this arc becomes the circular base of your cone. That's what this arc becomes, right? And then this point becomes the apex up here of the cone. And this is your O, and your M and your N comes together right here, M and N. So this length is this length, 12. And this arc becomes the circumference of the base of the cone. That's what happens now. And then this point now is up at the top here. And like you pull it up, it becomes a cone. So this is a flat, like a cone, it's like you have a cone, and you flatten it out first. This is the flat. This is the cone when it is flat. Right? It's called the net of the cone. Right? And then when you pull the middle up and join these two, it becomes the cone. All right? Just wanted you to sort of visualize that happening. So that's what they gave us down. See, this was 59.2. I'm erasing it accidentally. Centimeters. So that's what they gave us right here. So we can put down some information right after that. What we know is that this now was the radius of the sector above. So it is now the 12. This is the 12 centimeters right here. Right. This becomes the radius. But this now, this circumference is what it was before here, 35.2 from the arc length. And so this is 35.2 centimeters per meter. This circle, right? The circular base of the cone is 35.2. So we must calculate the radius of the cone. So what it is that we know that the circumference is this, and the circumference of this base becomes 2 pi r. So the 2 pi r becomes equal to that. So this and this, the 2 pi r, which would basically be the circumference of the base of the cone, is equal to what the arc length was a while ago in the sector. This is equal to 35.2. And trying to find r, so divided by the 2 pi. So it becomes r equals 35.2 divided by the 2 times pi. So you're working this out. Remember using 22/7 for that thing. Right? So if I were to show it, I'm going to shift this over and show it. We're really now working out 35.2 divided by 2 times 22/7. So you're working out to number of pi, so I must use 22/7. So that's why you're supposed to put in the calculator. So it's going to be 35.2 over 2 bracket 22/7. Close bracket. It's 5.6 exactly. 5.6 centimeters is the radius of the base of the cone. So we know that this length is 5.6. Then go 5.6 right here, centimeters. And then I want us to find the height of the cone. Well, this now is a right angle triangle. It's a right angle triangle. And this is the hypotenuse. That's the base. So okay, it's Pythagoras' theorem to find the height. Right? So the 8 squared will be equal to the h is going to be the square root of 12 squared minus 5.6 squared. Use Pythagoras' theorem. Why is that? Because initially, the 8 squared plus the r squared is equal to the 12 squared. So we're trying to make this a subject. We're going to subtract the r squared and then square root. So the h is equal to the square root of 12 squared minus the r squared. And the r is 5.6. I'm just showing the working down here, but let's write it in. The h down here is in Pythagoras' theorem. Is equal to the square root of 12 squared minus 5.6 squared. And we can also use a calculator. Square root 12 squared minus 5.6 squared. That gives me 10.6. Three significant figures is 10.6. So h is 10.6. 10.6 centimeters. When the answer is not exact, give it to correct the three significant figures. All right, that is that. Bang, bang, bang. Finish that part. Next part now says, calculate the capacity of a cone in liters. To get liters, you have to remember that 1 liter is 1,000 cm cube. 1 liter equals 1,000 cm cube. Now, the funny thing with CSEC is that sometimes they give you this, sometimes they don't. They didn't give it in this question. All right? The capacity of the cone is the volume. Talking about the volume capacity, the volume of a cone is 1/3 pi r squared h. I gave it this formula, but that's a formula good to know. 1/3 pi r squared h. So the volume becomes 1/3. The pi is 22/7. The r is, what was the r again? The r was 5.6 and the h is 10.6. 5.6 and 10.6. Yeah, 5.6 and 10.6. This is 5.6 squared, and the height is 10.6. That's the volume. I'm going to put that in the calculator. I'm going to get a third. Sorry. Right. Third times pi, which is 22/7, they said, times 5.6 squared times the h, which is 10.6. So that is giving me 348.245, and then I have 3 repeated. But I want it in liters. So get in liters, this is cm cube enough, centimeters cube. So to get it in liters, you have to divide by 1,000. because 1,000, 1 liter is 1 liter is 1,000 cm3. So to get the same liter, we divide by 1,000. So it becomes 1, 2, 3 here. So it becomes 0.348. I'm going to leave that 3 significant figures, liters. That is it. That is it. All right. Is that? All right. So 1/3 pi r squared h. Yeah, that is it. All right. That finishes that question. 2 marks for that. And then we continue down here. Next question, number 7. Pattern question. All right. Let's look at this one. It says the sequence of a design is made using black discs and white discs. So the first 3 designs in the sequence are shown below. All right, so observe it. Let's look at it. All right, so what I'm observing off the back, I have to observe the pattern. And let's focus on the black. So like below the black, 2 here and 2 there, and then 3 here and 3 there, and then 4 here and 4 here. And then basically complete the square, including these with the white, right? And then notice having 1 additional white on the top of the black here. So the next shape will have 5 of this, 5 black, 5 black, right? The next shape. See, they want us to draw the next shape right here on the diagram 4. All right, so I'm going to go for the black ink on this thing. I'm going to put 5 black and 5 black to continue that. 4 and 4. So next I want 5 and 5. All right, that's my observation. Whichever other way you want to observe the pattern, no problem. So it's 5 black. Let's zoom it to 5 and 5. 5 and 5. So 1, 2, 3, 4, 5. We have a white on top. We're going to put a home circle like that. Now 1, 2, 3, 4, 5. And you fill out the spaces with open circle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Not open circle, unshaped circle. That's my shape. That's my figure 4. Obviously, that's my figure 4. All right. So next question says the number of white discs W right here, and the number of black discs B right here, and the total number of this over here, which basically the sum of these two, sum of those two, give me the total number of this. The form that form each design follow a pattern. So they follow a pattern. Right? Clearly, if they follow a pattern in the diagram, then they follow a pattern in the numbers, right? That's what mathematics is. They follow a pattern in the shape on the diagram, and they will follow a pattern in numbers. That's all the power of math. All right, it says WT and B for the first 3 designs are shown to below. Study the pattern of numbers in the table, and we have to complete rows 1, 2, and 3. And let me go back for the blue ink. So the first thing I want to do, we have this completed already. Let's stop the video. Sorry about that. All right, so right. So the first thing I want to do with these questions always is to basically complete the formula down here. If I complete the formula, then it will help me to complete the rest of it. That's just how these questions are. So usually, even though they ask me for 1 and 2 first, I usually do my 3 first for the formula. I want to show what the formula is so I can double check my answers as I go. It's a matter of observing the patterns and putting the mathematical formulation to match the pattern. So if I look at it here, I see that the figure number, the figure number is P, or we have N here now, so it doesn't matter. Right, so it's the same number here times itself, right? So here then it will be n times n. N times n in the bracket. And you're adding back the same number. Same number. So you're adding an n again plus n. And then you add 1, consistently add 1. So it's plus 1. That is it. What does this work out? I'm going to just write on here. N times n is n squared. So this is really n squared plus n plus 1. That's the pattern for this column. In this column now, I observe that the values are increasing by 2 plus 2 plus 2. We keep adding 2. So because I keep adding 2, it means that 2n is a part of the formula. The first value has 4 in it. 2 times 1 in that first figure. 2 times 1 is 2. You have to add 2 more to get the 4. So the formula comes 2n plus 2. And then over here, clearly it's the sum of this and this. So to get this value, all I need to do is add this and this. Add them. Add these two to get this one. Because it is a sum of those two anyway. So I have to go figure it out. Just add those two and I'm good. So if I'm adding these, first, n squared is adding not to nothing else, so it's n squared. Then n and 2n is 3n. So I'm adding 3n. And then 1 and 2 is 3. So I'm adding 3. So this becomes my formula right there. All right. And once I have that formula, I can calculate anything after that. All right. So I'm completing this line first, where n is 9. So n is 9. I'm going to get 9 and 9 here. It's on the pattern. And a 9 here again. And then I'm adding 1 right here, plus 1. So it becomes 9 is 81. 81 and 9 is 90. 90 plus 1 is 91. So I'm getting 91 here. Right? So 9 squared plus 9 plus 1. 91. And then this is completed for me already. And here, when it is 20, it means that the n is 20. So I'm going to put 20 there. And this works out to 421. That's done for me. And so I'm going to take this 20. I'm going to drop it on the end to calculate the value for here. So it becomes 20, 2 times 20, which is 40. 40 plus 2 is 42. So this is 42. And then here again is the sum of these two. So if I add those two, I'm going to get 463. 463. All right, I'm going to get 463. Let's make sure 421 plus 42, 463. So right here is 463. And that's it. The table is complete. Next question says Stephen has 28 black and 150 white discs and wants to make a design 12. So here now is when n equals 12. N equals 12. All right. Design 12, then n equals 12. Explain why it is not possible to make design 12. So this is what he has in 28 black, 158 white. So basically I want to say how many black and how many white you need in design 12. And if he doesn't have enough, then he cannot make design 12. All right. So we're working for n equals 12. All right. So the black in n equals 12. We're going to paste the n right here in the black. Formula for black is, no, formula for black is this. 2n plus 2. All right. So for black, it's going to be, we're going to write the formula here. Black is 2n plus 2. All right. And the white is n squared plus 3n. No, plus 2n. So n squared plus n plus 1. N squared plus n plus 1 is a formula for the white. So we're doing the black first. So I'm dropping the 12 in there. So it becomes 2 times 12 plus 2. That's 24 and 2 is 26. That's 26. He has 28 blacks. So good, it's good to go with the black. He has enough black. Let's check the white. So for the white, this is the formula for the white. So it is 12 squared plus 12 plus 1. Let's see what that goes. It's 12 squared, which is 144, plus 12 plus 1. That is 157. This is 157. And 157 is actually greater than the amount that he needs. 157 is greater than 154. So it does not have enough white. So that is it. Not enough white. Not enough white. It does not have enough white, and so you cannot make the pattern. It does not have enough white. He only has 154 white, and he needs 157. So he cannot make the design for 12, for design 12. All right, that is it. All right, it says explain why it is not possible to make this. Yeah, it doesn't have enough white. He's short of 3 white. Needs 3 more white. All right, that needs 3 more white. He needs 3 more white. You cannot make design without 3 more white. 3 more white discs. One question to explain. That's why I'm writing all these things, all right? That's to explain. So to write something. Not enough white discs. He needs 3 more white discs to be able to do the pattern. All right, that's it. Move on to the semi-only one. All right, let's continue. This question now. Quadratics, like I said, quadratics right here. Complete the table for this. Remember, it's a quadratic function. This is negative. So when we're going to have a round shape, remember the values will be symmetrical. Once the x values are in the same interval, right? I mean, increase by the same amount from left to right. And the y values will be symmetrical, right? So you don't have to calculate all of them. Right? Let's look for the symmetry in the values. All right. So I want to calculate for the -3. All right. To calculate for -3, we're going to plug the -3 in the formula. All right. So for here, plugging the -3 in the equation is going to become -3 r squared. Remember, the x is -3. No, minus -3 squared. So it's minus x is -3 squared. Careful those negative signs. Then you're adding -3, and then you're adding 7. So that's what you're working out. All right. So it's minus the -3 squared inside this is 9. So minus 9. And then you're subtracting 3 again. And then you're adding 7. That is -5. So this is -5. So this matches this, -5. Matches that. What that tells me? That tells me that if when I come inwards to this one, I have to come inward back to 1 again. So this is going to be 1. It's going to be 1. All right. So whatever value this is, it's going to be the same value. That's right. No. It's going to come into, so this 5 will come here. I'm going to go from 1 this way. I have to go from 1 this way. So it's going to be a 5. It's going to be a 5 right there. All right. And then this is therefore going to be a 7. Right? But the values are symmetrical. And so my symmetry, my line of symmetry is in between here. It's my line of symmetry. So the values are symmetrical this way and that way from there. So you see, I don't have to calculate everything to understand the symmetric nature of the quadratic function. All right? But you can double check with the calculation if you want. So for example, you can double check this one, like plugging the -1 in there. So go to double check it here. For this value, it will be negative minus -1 squared plus -1 plus 7. In the calculator, the negative 1 squared here becomes negative 1, just the same. It becomes minus 1. You're subtracting 1 again, and then you're adding 7. So you get a 5, which is true. You want to check this one, then it will be plugging in the 1 there. So it will be minus 1 squared plus 1 plus 7. That will be 8 minus 1 is 7. So this is 7 right there. All right, and then if you want to get this one, you put the 3 right there. Now, if I'm in the exam, I'm not working out all of them. Once I calculate so that I can see my symmetry in the values, I'm going to put them in. These are the 2 marks for the question. It's too much work for that 2 marks. I'm going to use my line of symmetry, the symmetric nature of the quadratic function, as I did before. So you don't have to work with all of them. All right. For this one, if you plug the 3 in there, you see that this becomes 1, just the same. And I can just show it, just for the sake of showing it. Just for the sake of showing it, this one, we basically plug the 3 inside it, so it will be minus 3 squared plus 3 plus 7 should be 10 minus 9. 10 minus 9 is 1. So that will confirm it. All right. So basically, those are all you would get. All right. So to continue now, I need the axis of symmetry. The symmetry is halfway between the 0 and the 1. Halfway between 0 and 1 is clearly 0.5. And I want to know my y value. So my x value is 0.5 up here. Zoom it up. Erase this. So my line of symmetry is right between the 0 and the 1, which is 0.5. So this is 0.5. That's where my vertex will be. And then to get the y value here, I'm going to plug the 0.5 in that. If I want to calculate something, that's what I'm going to calculate. Because I want to know where that maximum vertex point is. So it will be negative 0.5 squared. Erase this. And then plus 0.5 plus 7. And I'm going to work that out. I want to know that value. All right, so it will be minus 0.5 squared. And then plus 0.5 plus 7. 7.25. So this will be y equals 7.25 when the x equals 0.5. So my maximum point, I know my maximum point already. My vertex point is 0.5, 7.25. Don't have to guess, I don't have to estimate, I know for a fact. That's what it is. I'll put back this line to show this calculation here. So this one goes here. So that is a table. All right, that is a table. All right. We're here now. Let's say on the grid below, we have to draw the graph. So to draw the graph, see they didn't plot any points for us. We have to plot all the points. All right, so let me just write down the points quickly. -3, -5, -2, 1, 0, no, -1, 5, 0, 7, 1, 7, 2, 5, 3, 1, and 4, -5. Right? I'm just copying them down to put them on the same page where the graph is. All right, so put them right here. All right. So those are the points that we'll practice. The first point is -5, -3, -5. -3, -5 is here. This point. Next point is Beatrice. It's my dog. -2, 1. Beatrice. -2, 1. -2, 1 is right here. Next point is -1, 5. -1, 5. -1, 5 is right here. Then next point is 0.7, that is here. You know, I had my vertex point, which was 0.5, 7.25. Let's put that one there as well. 0.5, 7.25. That's was 0.5 and 7.25. Let's get it precise. Let's get it precise. So this will be 7.5 right here. This will be 7.5. 7.25 will be right halfway between it. So right here we're talking about, you know, that's what we're talking about. It's a maximum point. Right, so that's a point there. And then the values are symmetrical again. So this point will be there, right? Symmetrical across from that. Then this one will be here, matching this. Okay. That's correct. Yes. And then this one across here over there. Here you can check it in a 3-1. 3-1. 3-1. And then 4 negative 5. 4 negative 5 will be down here. Those are your points. Right? And I was careful to include my maximum point. So when I draw my graph, it goes up to here. All right, so this is our maximum point. And so now we just need to just draw the smooth curve. Don't use any ruler. It's a curve, it's a quadratic curve. And don't draw a straight line across here. So it was very important for us to put that point in. All right, and that's how CSEC setting this question these days, testing your knowledge. If you know that there's a vertex point, right? I have to calculate that vertex point. All right, so a smooth curve to the points. Just draw a smooth curve as best as you can to the points. That's not looking so good. Let's do this part over. All right, that's it. All right, so that will be good enough. CSEC will accept that. All right. What question do you want us to do? So write down the coordinates of the maximum point, maximum or minimum point. It's actually a maximum, right? So we know it's a maximum. So we can indicate that it's actually a maximum. Write it here. And we work it out. It goes right here, 0.5, 7.25. So you don't have to write the wrong thing when you actually can know the right thing. Mathematics is the most exact science. So when you can know the right thing, write the right thing. So it is 0.5, 7.25. 0.5, 7.25. No need to estimate when you can know the right thing. You have all the values, you have the graph, the equation, calculate the right thing. No need to estimate. That is it. All right. Next part says, write down the equation of the axis of symmetry. So the axis of symmetry is that vertical line that divides the graph in two halves. One half is the mirror image of the next. So the vertical line that passes through the apex point right down here. That is the axis of symmetry. Crossing the y-axis at the x-axis at 0.5 or half. So it's x equals 0.5 or x equals half is the axis of symmetry. And that line comes all the way down. That's the line that down. X equals 0.5. So it's x equals 0.5, or you could put x equals half. Whichever one, it doesn't matter. Axis of symmetry. This part says Use your graph. So we want to use a graph. We don't want us to calculate. Use your graph. Find a solution of this. This basically are the roots on the x-axis. These are the roots on the x-axis. Points of the graph intersect the x-axis. I say it's where function becomes equal to 0. That's referring to the roots on the x-axis. And roots are the x values of the graph intersect the x-axis. See? X equals, right? So we're looking for it on the graph. I need to read the scale properly. We'll just write down something. If you look at the scale of the graph, horizontal scale, it is 2 centimeters to 1 unit, right? 2 centimeters to 1 unit across here. So basically there are 10 lines. 10 of those are a millimeter line between here and here. So each of these little lines is 0.1. So to be 0.1, 0.2, 0.3, 0.4, 0.5 negative, right? And the points we're talking about in this question would be this point here is a purple. This point here where it crosses the x-axis. This point here crosses the y-axis. All right? And this to me is 3.2. That's one root. And the other root is negative 2.2. Negative 2.2. Use a scale. All right? So I'm going to write those down. And the question said use the graph, and by putting these marks on the graph and leaving them there, that is showing the examiner how I use the graph. All right? So it's a negative 2.2. Put the smaller one first. This is negative 2.2. And the larger one is 3.2. I can test if these values correct or near correct by plugging them in the formula there to see if we get the 0. Right? In the exam, you can just check it to make sure. I'm going to put minus 3.2 squared, 3.2 squared plus 3.2 plus 7. I get negative 0.04. That is close enough to 0, so I can accept that, right? Because it's not exact. And I'm going to try the negative 2, the negative 2.2. So I'm going to put negative bracket, negative 2.2 close bracket squared. And I'm going to add the negative 2.2 where the x is, and then I'm going to put plus 7. I get 9. What did I do wrong? Oh, this is a negative. I put a 1 there, it's supposed to be a negative. Right, so you see you get the same thing, almost 0. So you know that these answers are good answers, right? We're using the graph, and we're giving the answer to 1 decimal place. Or we use the graph. You want the actual values of the solve the quadratic equation, which we're not going to do. You have to use the quadratic formula or completing the square because that can be factorized. Can be factorized in whole numbers with whole numbers. All right. So let's go. It says on the grid, we have to draw the line through these 2 points. Draw a line through those 2 points. Negative 3, negative 1, and 0, 8. 0, 8. So those are the 2 points I want to draw on the graph. Let's copy that. Negative 3, negative 1, 0, 8. Negative 3, negative 1, 0, 8. All right, let me use that green for a different color. All right, so let's say paste it up here. Paste it up here, what we want. So 1, negative 1, negative 3, negative 1. So negative 3, negative 1, negative 3, negative 1 is this point right here. 1, 0, 8 is on the y-axis. 0, 8 is all the way up here. 0, 8 is all the way up there. That's 0, 8. I want us to draw a straight line. So that line, use your ruler. I'm not sure if you're going to intersect the graph. You go like that. Looks like it is not intersecting the graph based on this. Use your ruler and draw it. Right? So it says on the grid. Page 24, the same one, page 24. Page 24, yeah. Same grid. On the grid on page 24. Draw the line. And I said determine the equation of the line. Wow. So determine the equation of the line. I already know the y-axis intercept. So the C is already 8. What I want now is the gradient. I can look at the graph and see the gradient now. But the gradient M, remember it equals rise over run. I have the graph, I don't have to calculate anything. You can calculate it using these, difference in y or difference in x. But then you can also use a graph. Count the rise and count the run from here to here. All right? Just make sure you use the correct scale. Be mindful of the scale. So in that case, let's use the red. The rise is from -1 up to 8. It's a rise of 9. Right? It's a rise of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is a rise. A rise of 9. It's going to have a positive gradient. Rise 9. All the way up here. A rise of 9. 9. And this is a run. From here is a run. The run is 3. That's it. This is 3 units. The run is 3. So it's 9 over 3. So rise 9, run 3. 9 over 3. 9 over 3, which is 3. So the equation therefore is y equals 3x plus 8. You're done. If you wanted to calculate the gradient using the coordinates, so answer or for the gradient, which is difference in y by difference in x. So let's say using this point minus this point. Right? So it's 8 minus a -1, difference in y. It will be 8 minus a -1 divided by a run. 0 minus a -3. 0 minus a -3. So you get the same 9 minus minus is plus over minus minus is plus 9 over 3, which is still 3. That is it. So going to 3. So you could calculate it, but you could get it from the graph as well, rise over run. All right, so that is that one. All right, next question. You could use 2 other points for the gradient. So for example, you could use these 2 points to get the gradient just from here to here, right here. And so instead of going all the way up there, I could have said, let's do the reading to show it. I could have said this point to this point, rise 3, 1, 2, 3, rise 3, run 1. So between -3 and -2, run 1. So rise through 1, I'll give you 3 equals 3. So gradient still will be equal to that. Right? 3 over 1 is 3. So that is that. All right. So let's go next question. The next question, I don't think I need calculator. Maybe I do. So it's a circle theory. So let's go. Question says L, M, N, and R are points on the circumference of a circle. So this is right off the bat, cyclic quadrilateral. This one. 4 vertices on circumference. Right, center O, PQ, that tangent, at the point R, and the angle here is 48 degrees. Here, that's the angle between this tangent and this chord. It's 48 degrees. And then the angle at the center right here is 156. 156. Question now says, find the value of each of the following angles given reason for each of your answers. Show all workings were appropriate. First one, angle R. So angle R is this one. Now, what I always say, you want this angle, find the chord, go back on the angle, find the chord or the arc that is subtending the angle, which is this chord. chord is subtending an angle of 156 at the center right now. So we can use a center rule. This angle over here is half of this one, half, right? Because the angle at the center is twice the angle of the circumference. So simply, the angle R is going to be equal to half of the 156 degrees. Half of 156. Because the angle at the center is twice the angle of the circumference, right? So that would be 78 degrees. So angle R is 78 degrees. And the reason is that angle at center is twice angle at circumference. Write it down here. Angle center is twice the angle circumference. So one of the circumference is half. So 78 degrees is the angle circumference, half of the 156. I'm going to put on the diagram right now. So this angle right here is 78 degrees, right here. All right. Next angle I want is angle E on the diagram. Where's that angle now? Angle E is this one out here. Now that angle is the angle between this tangent and this chord. So we're talking about angle between a tangent and a chord. Angle between a tangent and a chord is equal to the angle subtended by the same chord. So the angle subtended by that chord at the circumference is 78. And between the tangent and the chord up here, which is 78, is equal to the angle between the tangent and a chord. So this angle therefore is the same 78 degrees. Angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment of a circle. So it's called the alternate segment rule. Right? So it's also 78 degrees. Alternate segment rule. So this angle is equal to angle R. It's equal to angle R, which is 78 degrees. And the reason is that angle between tangent and a chord equals angle subtended by the chord at the circumference in the alternate segment. Okay, so something by the chord in the alternate segment. In the alternate segment. That is it, right? At the circumference in the alternate segment. But even if you stop this explanation right here, angle between a tangent and a chord equals angle subtended by the chord. If you just write like this, they'll give you the marks in, right? But sometimes it's good to say in the alternate segment. But that is it, right? We'll have indicated the correct reason there. Next angle I want is angle A. Let's look at the diagram with angle A. Angle A. All right, let me erase these lines. I don't need that angle is 78 degrees. Right, right. This angle here is 78 degrees as well. As you find the angles, you put them on the diagram. But sometimes they help you find other angles. We need to find this angle now, A, up here. That angle is a part of this majority of the cycle quadrilateral in blue. One of the angles in this cycle quadrilateral right now. This one. So that angle, A that we want that I've marked in red, is supplementary with this angle. Those two angles add up to 180 degrees, but they are opposite angles in a cyclic quadrilateral. So it means that if we can find this one, in here, then the 180 minus, and we get this one over here. So what is this one in here equal? It is 180 minus the sum of these two angles, because total angle of straight line is 180 degrees. I can show it here. It's 180 degrees minus the 78 and the 48. 180 minus the 78 and the 48, which is, I'm just working it out here quickly. 180 minus 78 minus 48, that's 54. So this angle over here now that we want, the A, 180 degrees minus 54 degrees, which essentially gives us the same thing, right? Gives about the sum, which is 126 degrees. All right, so that is it. All right, so that says 126. Well, let's put the diagram down. So first, we're going to say I'm going to straight line down here. Tell them that this angle is 54 NRL. NRL. First, to get this angle, I'll tell them what angle NRL. Angle NRL is 180 degrees minus the 78 and the 50 and the 48 and the 48, which gave us the 54. And the reason for this is that angles in a straight line at 180 degrees. Angles on a straight line through a point, angle on a straight line through a point, add to 180 degrees. Angle on a straight line at 180 degrees. That's through this point. So the angles through this point are, so these three angles, 1, 2, 3, that completes the straight line through the point. They add to 180 degrees. So the missing angle inside here is 180 minus the sum of these two. That is 54. Then now we're going to use the cyclic quadrilateral rule. And the opposite angles in a cyclic quadrilateral are supplementary, meaning they add 180 degrees. Then we're going to send out the angle A that I want. Then angle A equals 180 degrees minus the 54 degrees, which is a 126 degrees. This for that is that opposite angles in a cyclic quadrilateral, let's say cyclic quad, are supplementary. Supplementary. And supplementary means that they add to 180 degrees. That's what supplementary means. The opposite angles in a cyclic quadrilateral are supplementary. And that quadrilateral in blue is cyclic because 4 vertices on the circumference of the circle. When you have a quadrilateral with 4 vertices on the circumference of a circle, it is cyclic. It is a cyclic quadrilateral, and the opposite angles are 280 degrees. All right, so that finishes this question. All right, next question down here. Once I see this, I know I'm going to have to use cosine rule. And given a triangle that is not a right angle triangle, 3 sides, I have to use cosine rule to find an angle in there. Any angle in there you want to find, you have to use cosine rule. All right, cannot use sine rule right now. The diagram below shows a triangular field LMP and horizontal plane. We have these dimensions, right? Naturally, we're going to want an angle. calculate angle MLP. MLP is this angle right here. Let's call it theta. I'm gonna write equal. I'm gonna call it equal theta. Now let's not call it theta. Let's call it something. Let's call it angle. Let's call it theta. So I'm gonna call it theta and put it on the diagram. The reason I don't want to call it theta, because I usually call bearing angles theta, you know. Now let's call it alpha. Alpha. Let's call it alpha. When you reference a diagram and put these things on your diagram, you can use them to reference your work. Okay? You have to be writing what angle, writing out the name of the angle like that. I'm gonna call it alpha. I have to use cosine rule. So we're treating it as if it's two sides with the angle between two sides, and then this is the side opposite the angle over here. Right? And you're setting those values in the cosine rule. Right? So it's almost like you would have normally you would have wanted to find this side if you have these two. Normally, if you have these two, let's look at it. Normally, if you have these two sides and the angle between them, you would have wanted to find this one. And so you would start out the cosine rule that way. So it's like starting out the cosine rule with this as a subject. Right? So cosine rule, that's why it's the cosine rule. I'm using it for alpha, using it to find the alpha. So you start like Pythagoras' theorem. So these are your two sides, and this is the angle in between. So the side that opposite those, the angle is that one. So that becomes the subject. So it's 180 squared equals 150 squared plus the 120 squared. That like Pythagoras' theorem. Then you subtract a piece. So it's 2 times the 150 times the 120 and the cosine of the angle between them, which is the alpha. I'm going to be solving for alpha. And you see, you don't ask us to find angles using cosine rule a lot. But the few times that they set it, we have to be able to do it. We have to remember, and we have to remember that it can be used to find angle as well. And it is in the case when you have three sides and you don't have an angle in a triangle that is not a right angle triangle. Cosine rule you have to use. So basically, I want to make this a subject now. You can make one transpose now. So I would take all of this, bring it over here, make it positive. Take this, bring it over this side, make it negative. And then we're dividing by that. I'm going to write what it is in. Generally speaking, we do a lot of space to do this calculation, right? So a small amount of space. What's going to happen is that the cost of alpha is going to be these two remain 150 squared plus 120 squared. Then this will be subtracted over there, minus the 180 squared. And I'll be dividing by these. When I bring it over first, then I will have to divide by them. So I'm dividing by 2 times 150 times the 120. And then know that alpha is going to be the cost to the minus one of that. So watch it now. I'm going to just set it up now. Let's shift this over. On a video and say you'll be able to see it. I'm going to do cos to the minus one of this now. So the alpha is cos to the minus one of all of this. And I'm moving the alpha. And that's another reason why I tell my students use a pencil. Because you can make these adjustments and erase. But you don't have a lot of space to work with. Right? And then the alpha now, you drop this in the calculator and you have your alpha. Right? You drop that in the calculator. And you have your alpha. So I tell the students work with a pencil. So you know you can just put in a part, erase it, move it. And I don't have a lot of space to be doing a lot of steps to transpose this, right? So let's set it up. So it becomes cos to the minus one. I type in back exact same thing. A fraction 150 squared plus 120 squared. And then you're subtracting 180 squared. And putting that over 2 times 150 times 120. And it gives us 82.8 degrees. And let's check the values just to make sure. 150, 120, 180, 150, 120. All right, so that is it. 82.8 degrees is the angle there. 82.8. Now, might ask me, why don't put 83? When you're given an answer in degrees that is not exact, and the question did not tell you how accurately you must give your answer, you give it 1 decimal place in degrees. When it's degrees, 1 decimal place, or 3 significant figures. So this one satisfying both conditions. It's 3 significant figures, but also because it is angles in degrees, I'm giving it 1 decimal place. So that is my answer, 82.8 degrees. I'm going to put it on the diagram now. 82.2, 82.8 degrees, 82.8. Don't put it here on the diagram. And let's put it in both, 82.8 degrees. This angle is 82.8 degrees. I want to see it on my diagram. Right? Because naturally, we're going to have to use it later on. That's how these questions are. All right, so this finishes this. I will bring up the next part of the paper now, which is on another file. All right, so it's on another file. I'm going to put on the next side of the screen over here. Another file. So this is the next part of the question. Same question. That's what the paper came to. All right, so this is a diagram still. Question says you have to know. Calculate the bearing of P from L, and I always say know the from position. Or they're telling us the bearing of P from L is 210. So from L to P, the bearing of is 210. Show that on the diagram. So from L to P, the bearing is 210. That means if we were to show it, that from position L, this is an outline at L. It's the angle through which you have to turn to the right to face P down here. That angle is 210 degrees. That's what they're basically saying. That angle is 210. What angle they want? They want the bearing of, they want the bearing from L to M. So they're asking us now for the bearing from L to M. Which angle are they asking us for? From the same L to M. So if I were to show that in a different color purple, this is the north line again. They're asking me for angle to which I have to turn to the right around here now. Let me put this 210 a little bit smaller. Right, a little smaller anyway. So it's a red angle is 210 right here. Put it inside here, 210. That red angle is 210. The angle that I'm asking for now is the bearing from L down to M. All right. So just to make sure we understand it, it says that the from position is not first. I'm going to which I have to turn to the right to face M down here. So that is asking us for that purple angle right here. This question is asking for this purple angle. Let's call it theta. Bearing of L from M from L. And I'm saying I'm calling that angle theta on the diagram. Now, theta is clearly the difference between 210 and 82.5, 82.8, because the angle all the way around here is 210, and in between here is 82.8. So clearly, theta is the difference between them. I can literally put on the diagram right here as well. The diagram we can write this equals 210 degrees minus 82.8 degrees. Then put on the diagram. Here we're going to write it. Theta bearing angle that we want is 210 degrees minus 82.8 degrees. You work it out. Remember, you give it the 3 digits. So you're going to correct it to 3 digits. All right. So I'm just calculate it on my calculator here. So it's 210 minus 82.8. So the thing 127.2 degrees, but bearings are usually express it as 3 digits. So 33 digits. So this is my answer right here. I'm going to say IE bearing start 127. Right? That is 127. All right, let's continue. It says now, calculate the value of angle NLP and hence find the bearing of L from P now. The first angle I want is angle NLP. So working back with this diagram. NLP. The question is now asking us, let's put that diagram in a different color. That angle is a different color. Asking for this angle here, so green. That angle is kind of easy to find. Not kind of easy. It is easy to find. Why is that? Because total angle around this point, so to go all the way around, I go all the way around, it will be 360. We have up to this point is 210. The remaining angle in here is 360 minus 210. Right? So we can mark it on the diagram. Right? 360 minus 210. That looks like 150 degrees. It's this angle in here that I want. It's that angle that I want. Alright, so that angle is that. Work for first. Put on the calculator on the thing. Angle NLP is 360 degrees. 360 degrees minus the 210 degrees around there. Shift it over. Which is 150 degrees. Then we want the bearing of L from M. So always note the from position again. Going from P to L. From P to L. We must measure from position from P to L. So we're going from P back up to L. So show that now. So basically, we need to show the north line at the from position P, which is right here. And we want the bearing up to L. So it's a clockwise angle right here that we want. That causes us to face L. So this angle inside, we're going to call it beta. What happened now is that we have these two angles are co-interior angles, these two are what we call U angles. This is our U. Like we have a vertical line here, that north line and this north line, they are parallel. So this line completes that U. These two angles are co-interior angles. They add up to 180 degrees. So this angle inside here says 150, and this angle down here is just 30. That angle is just 30 degrees. So this angle here that I want, this angle side here will be 180 degrees minus the 150 degrees, which then is 30 degrees. So the bearing angle down here that I want, bearing of L from P is beta on my diagram, where the beta comes 180 degrees minus 150 degrees. So the beta is 30 degrees. Because it's bearings, you're going to put 0, 30 degrees. That is my answer right there. All right, 0, 30 degrees. Then from down here, oh, and come here. Okay, stand down. Stand down. All right, nice and easy. We're gonna go now to the next question. This is the last question. So I'm just going to go on the left side of the screen. Just going to go here. One last question to do. And then we're done. So that nice paper. Nice paper. All right, let's see. Come on. All right, number 10. So this is matrices transformation, right? So I need to calculate for this one. All right, let's go. So this question now gives us matrix A and B are two transformations. So this one is the anticlockwise 90 degree rotation about the origin. I advise my students to learn them and know them. CSEC is giving it to you for free, but I don't do that all the time. This one is a y equals minus x reflection matrix, reflection line y equals minus x. So this is A and that is B. Question says determine the elements of matrix C, which represents an anticlockwise rotation about the origin of 90 degrees. So they're talking about A right here, followed by a reflection line y equals x. So they're talking about B right here. So the question is really A followed by A followed by B question. And A followed by B is A followed by B is B times the second one times the first one. That's how we get that matrix. So C that I want is equal to BA. The matrix C is equal to BA. So multiplying this one times this one. All right, and you must get back one of those matrices that the formula with. So multiplying 0, minus 1, 0 with 0, minus 1, 1, 0. Remember, when you multiply matrices now, multiply the rows of the first matrix by the columns of the second matrix. So I'm just going to write what the answer matrix is supposed to be. All right, so let's do it. So the first 4 values we're going to get. First value here is in the first row, first column. So to get that first value, we're using this first row with this first column. So it's first element times first element, second element times second element. First element times first element, second element times second element. 0 times 0 is 0. Negative 1 times 1 is negative 1. So the value here is negative 1. And this value out here now it is in the first row and the second column. So to get it, we're going to use this first row with this second column. We're multiplying the same sequence again. First element times first element, second element times second element. So that becomes 0 times negative 1 is 0, negative 1 times 0 is 0. So this value becomes a 0. And the value down here that we want now, it's in the second row, first column, that's this value. Second row, first column. So we're using this second row with this first column. First element times first element, second element times second element. First element times first element, second element times second element. Negative 1 times 0 is 0. 0 times 1 is 0. So this value here is 0. And you're supposed to get the zeros across on the same diagonal. And the last value that I want down here is the second row, second column. So to get it, we use this second row with this second column. Then again, it is first element times first element, second element times second element. Negative 1 times negative 1, and 0 times 0. First element times first element, second element times second element. Negative 1 times negative 1 is a positive 1. 0 times 0 is 0. So this becomes a positive 1. And I look at this, I know that this is a y-axis reflection matrix. Y-axis reflection. You have to know them on site. So you have to figure out stuff that they can know. That matrix is for reflection in the y-axis. And they're going to ask you, describe the geometry describe geometrically the single transformation represented by C. It's a reflection in the y-axis. That's it. It's a transformation. Reflection in the y-axis. Let me change these values to purple. The color of these purple. Change them to purple. Match the color of the piston. Let's go back to blue. All right, so this now wants us to describe C. See, a reflection in the y-axis. Just learn the matrices. You have to figure it out. 2 marks, we can fast. You have to figure out stuff that you can know. Right? And these are the matrices 6 you're always setting. So just learn them. All right, next part. Next part says transformation T defined by this matrix. All right, it says T maps this onto this. All it means is that you multiply T times this, T matrix times this equals this. That's what it is. That's how the matrix works. That's how the matrix works. You multiply the matrix by the object point to get the image point. So when I do the setup, so it becomes our equality of matrices question. So it's a matrix of 1, 2, k negative 1 times the matrix for this point is 2, 3 is equal to the matrix for this point is 8, 15. It's the equality of matrices question. And you want to do a calculation that uses the k. Remember, you always have to use the rows for the one column. So what I know is that this second value, the second row, that second row by this column equals that 15. Right? Let's see if the first value is correct, because this is supposed to be this times this. It is correct because this times is 2, and this times this is 6. 2 or 6 is 8, so the 8 is correct. But the 15 right here is the product of this row and this column. That's what we're saying. So basically, a solution go like this: the k negative 1 multiplied by the 2, 3, that is equal to the 15 right there. That's what it is. So multiply that row by that column and work out the 50, right? Work out the k. So it's k times 2, that's 2k, and minus 1 times 3, it's minus 3, that equals a 15. And that implies, over the 3, and add I get 18. 18 divided by 2 is 9. So the k is 9. You can check it. 2 times 9 is 18. 18 minus 3 is 15. So you know that that is correct. So sometimes as you work, you can just be checking along. Check. Let me show that the answer after this. K equals 9. Done. What is it? All right. Then we continue down here. We'll come to vectors. So for the first time in a long way, they did not give a diagram. Most times they give a diagram. Vector diagram. I like vector diagram question. But this is easy step. Remember, vector is just how you go from point to point. At this level, that's simple as that. How do you go from point to point? Like translation. Question said the following vectors are defined as shown below. Wx is this one, 5, negative 1. Xy is negative 3, 7. Zy is 8, negative 7. Determine each of the following. Determine a vector. A means any vector now. Determine a vector other than the 5, negative 1 that is parallel to Wx. Wx is this. So if a vector is going to be parallel to Wx, it's going to be equal to a multiple of Wx. So that vector can be equal to, for example, 2 times 5, negative 1. Or any value you want. It can be half. Any value times it can be 3. It can be 10. Right? It can be 10. Any multiple of it will work. Any multiple. So let's say I'm going to use 4. It doesn't matter. It can be 3 or 2. Any constant multiple. It can be 2/3. It can be 2/3. It can be 1/5. any multiple of the 5 -1 will be parallel to it. I'm going to use 4, just for no particular reason. I'm going to use 4. Right? So any vector. In fact, let me use k. Let me say k. Let's say k, and it becomes 5k minus k. And I can say k is any real number. K is any real number. And do that. K is any real number. So illustrate if. So you can say where k is any real number. You want it greater than, you want it not 0, right? Any real number, because if you have 0, you don't have a vector, right? It's 0, you don't have a vector. Any real number that is not equal to 0. Any number that is, any real number that is not equal to 0, positive or negative. It can be negative too, you know, because the negative means that it's going in the opposite direction. But still parallel. But to assume that parallel means that it's going in the same direction, you can say any real number, just put greater than 0. Any real number, k greater than 0. So I want to ensure that it's going in the same direction. So we can say example, that parallel vector v, let's call it v, a vector parallel v. Let's call it parallel vector v. The parallel vector v would be, put that equal 4 or 3. 3 times 5 -1, which should be 15 -3. I think most persons would just use 2. 2 does sound like the natural number to use, and to be 10 -2 in that case, if you use 2. 10 -2. Right? But I'm just using 3 times any real number that is greater than 0. You don't want 0 because 0 means you don't have a vector. And the reason I'm not using negative numbers because opposite direction, but and parallel vectors are usually thought after be going in the same direction. If they go in the same direction, there's a positive multiplying factor, positive multiple. When vectors are parallel, one is a multiple of the next. Right? It's just one mark for the question enough. So I'm just explaining more than needed actually. Next vector we want is WY. So basically I want to use these vectors to see how you can go from WY, or you can combine these vectors to go from W to Y. Right? So I have WX and I have XY. So naturally, if I add these two, it's going to take me from W to Y. So I'm going to write this equals, I'm going to go from W to X. That's what this means, you know, to go from W to Y. I'm going to go from W to X. And then I'm going to go from X to Y. That's what it means, you know. Going from W to Y is the same as equals mean equals equal in the vectors equation means is the same as going from W to X plus in the vector equation means and then going from Y to X. So I read the equation now, it is going from W to Y is the same as going from W to X and then going from X to Y. Because vectors at this level is basically about how you go from point to point, right? And so this becomes the WX vector is 5 minus 1, and the XY vector is -3, 7. And let's add the values now. So that becomes the 5 and minus 3 is 2, -1 and the 7 is 6. That is 7 minus 1 is 6. That is the answer. That here. All right. Now we want to go from X to Z. So let's look at it. X to Z. So this one has X in it. And then this one has a Z in it, right? So now X in it too, you know, but the thing is that this one also has a Y and this one also has a Y. So those two can be combined. Now, if you want to start at X and you want to bring it to Y, then naturally you want to go from X to Y first, and then you go from Y to Z. That's what you want. And the question actually gave us ZY. zy is just the inverse of xz. So if you give us zy, then yz, I don't know what I said a while ago. Yz is the inverse of zy. So if they give you zy and you really want yz, it's going to opposite direction. And opposite direction in vectors is taken with the negative. So this will become a negative 8 if we're going in the opposite direction, and this will become a positive 7. And so if we want to use yz, then this is it, negative 8, 7. And that's what we need down here for this question, yz. Right? So we're using the xy and the yz. So the xy is the same, negative 3, 7 right here. The yz here, negative 3, 7. So it's negative 3, 7. And they're adding the yz that we formed up here. And they give us zy, but we really needed yz for this question. Negative 8, 7, negative 8, 7. So the answer for this is negative 11, 14. 7, oh, this one looks right. Hold on. This is 7 and 7. All right, what is it? All right, so negative 11, 14. That is it. Plus negative 8, 3 and negative 8 is negative 11, 11, 7, 14. So this is the answer right there. That done. Next part, the one, the modulus of x1. Next, I'm done an easy exam. The modulus, but the modulus is the length. What is xy again? Xy is the same, negative 3, 7, negative 3, 7. So the modulus of xy right here needs a length. Become the square root of 3 squared plus 7 squared. 3 squared plus 7 squared. That's the length of the vector. Well, this is 49, 77, 49 and 9. So that is about 58. Square root of 58. I must say units. The modulus is length. I must say units. That is it. So double check that. Sure. Is it? And you don't have to work this out, you know. That's it. All right. So if we were to show why this is so, it's like you have the vector x1. If x is a point right here, right? If x is a point right here, so x is a point right here. This is x. Negative 3, 7 go from 4 to y means that they go back 3 this way and then go 7 up and so if x is right here and y is right here, this will be negative 3 and this is 7. That's what it means, you know. So the xy vector will be this line that I'm going to draw in red. And this means that you're trying to find the length of this line. Trying to find the length of this line. That's why it becomes Pythagoras theorem. Square root of 3 squared plus 7 squared. This length is 3, you know, this length is 7. And that's why we don't have to put the positive, we don't have to put the minus in the formula right here. So that is it. That is it. The end of this test. All right, so I'm going to share this video on my YouTube channel, and then I send it to the group. The process can go and have a look. All right. So if you find any mistake in there, I'm not checking it over. If you find any mistake in there, you can let me know. Send me a message and let me know. All right, because I just woke up this morning and decided to work it out for the class. And for the wider public as well. Even though I expect that this paper, we're gonna have a repeat paper. Maybe in some regions where there was no leak. And so CSEC will investigate and decide whether or not there exists the need to redo a paper. Set another paper, which I think is what will happen. All right, so we might have another 2023 paper to work on. That will be fun. I think that will be nice to have another 2023 paper. The more papers we have, the practice from, the better we get. All right, guys. So that is it. So bye. I'm gonna end it.